now we're going to do question 2, which reads as follows. An empty lift is supported by a steel cable. The lift moves upwards at a constant velocity, while an upward force of 2,500 newtons is applied by the cable. Ignore the mass of the cable and all frictional forces. Now, 2.1.1, we are asked to state Newton's second law of motion. So, Newton's second law of motion states that if you have an object like this, right, and you have a force acting on this object, this force will cause the object to accelerate in the direction of the force. So the force is going to the right. If this, let's say this direction is to the right, so which means this object will accelerate in the direction of this force here, right? Because the force is equals to ma. So once the object moves in the direction of the force, it will result in acceleration being directly proportional to the force, but acceleration being inversely proportional to the mass of the object, right? So let me state it. When a resultant force acts on an object, the object will accelerate in the direction of the force, right? So now causing acceleration to be directly proportional to the force and inversely proportional to the mass of the object. So that is your Newton 2. Question 2.2 says that draw a free body diagram indicating all forces acting on the lift while it travels upwards at constant speed. 2.2, we having this lift object. I'm gonna indicate it using this dot here. So this is our lift and forces acting on it. The first force is the force of gravity that is acting on the lift, and the applied force which comes from the tension that causes the lift to move vertically upwards, right? So which was given as 2,500 newtons, right? So you don't need to write it, but you can simply say force, right? So yeah, this is the free body diagram of the lift. So 2.3, write down the magnitude of acceleration of the lift as it moves upwards. So remember, they said acceleration, they didn't say gravitational acceleration. So the the object is moving in the direction which is up, right? So meaning there's only one acceleration that is acting on this body. It is the gravitational acceleration, which has the force of gravity being F of g, right? So this means now that the acceleration of the object, because it's moving vertically upwards, then our acceleration is going to be 0 meters per second squared. 2.4, calculate the mass of the empty lift. So now we want to know the mass of the empty lift. We must make sure that we take into account the information that was given in the statement. We have the applied force of 2,500 newtons, right? And what we know is that it's traveling at constant speed. So the lift is traveling at constant speed, right? And what we also know is that the free body diagram of the lift is the force applied and the force of gravity below. So we're just going to write our F net. So F net is equals to MA, right? So the net force is the force applied minus the force of gravity, right? So that is our net force of this problem here. So it's going to be force applied minus force of gravity is equals to MA. Remember that we were told that the lift is traveling at constant speed. So what that means is, you know, speed is equals to displacement over time, right? But acceleration is equals to speed over time. So if this speed is constant, then it basically means that the final velocity minus the initial velocity will give you 0, right? Divided by time. So acceleration will definitely be equals to 0 in this case. So meaning you have f of a minus f of g is equals to m, because we want the mass, but we know acceleration is equals to 0, right? So we have f of a minus f of g is equals to 0, and the force applied is 2,500 newtons minus, so f of g is equals to mg is equals to 0, and we have 2,500 minus the mass we don't know, but we know that g is 9.8, and then we equate to 0. Then we can transpose this portion to the other side. So we have 2,500 newtons is equals to 9.8, and then m we divide it by 9.8, we divide by 9.8, and our mass in this case is going to be 255.10 kg. Now we're going to do 2.5, right? When the 2,500 force on the cable is replaced by a force of 3,000 newtons, the lift accelerates upwards. Calculate the magnitude of this acceleration. So now that we have increased the force that is applied, the lift starts to accelerate, right? So now we want to know the acceleration of this lift. So what we need to take into account also in this problem is the free body diagram of the lift, which we know the force acting on is the force applied, which in this case our force applied is going to be 3,000 Newton, and we know that it's F of g, which is the gravitational acceleration, or the gravitational force, sorry. So we are going to write our F net. So it's going to be F net is equals to ma. We are looking for the acceleration. Alright, so our F net is going to be the force applied, because the object is moving vertically upwards, so the force applied is going to be positive. We're going to take upwards as positive, minus the force of gravity is equals to ma, right? Remember that the mass is calculated as 255.10 kilograms from the previous question. So the force applied is 3000 newtons minus our m, which is, so it's going to be mg is equals to ma, right? And 3000 newtons minus our mass is 255.10 multiplied by 9.8 is equals to 255.10. Let me remove this, and then it's going to multiply with the acceleration. We're just gonna divide this whole thing with 255.10 divided by 255.10, and then our acceleration is going to be equals to 3000 minus 255.10 times 9.8 divided by 255.10. So please punch this into the calculator. You should get your acceleration being equals to 1.96 meters per second squared. Now we're going to do 2.6, which says that identify the force that forms a Newton 3 force pair with the weight of the empty lift. So if we draw the lift, it looks like this, right? And if we just consider this flow of the lift, if you just enter a lift, if this is you entering the lift, you know, okay, you're gonna enter here, and this would be the flow. So this is the flow of the lift, and yes. So now there will be a force of gravity acting on this lift, and then because there's tension ropes that are attached to this lift, moving it vertically upwards or downwards. And so let's just consider the tension to be here. Let's say there'll be a force here, right, causing upward movements instead of me considering this tension. So this is actually the force that causes Newton 3, right? Because the lift weight, or the gravitational force of the lift, wants it to move downwards, but the force wants it to move upwards. So you can simply write the force of the empty lift on Earth. So that would be your answer for this question.